negocio. Un atraco singular.
Because we're not stealing anyone's money.
And so we came up with a plan to conduct the biggest heist in MDP history. Jonathan was created and we had big plans for him. We worked day and night, devoted our sweat and tears to make Jonathan the strongest ever bank robber. After putting Jonathan through countless trials, it was finally time.
Hey guys, we should test the prototype.
After clicking on the set button, you can drag the obstacles from the sidebar onto the grid, and after clicking on the done button, you can click on each of the obstacles to rotate its image direction between up, right, down and left.
After this, you can press the send obstacles button to send over the obstacles coordinates, direction it is facing and its ID. Next, we have the task 1 and task 2 buttons, which will send over algo start and STM SP respectively, and will start the timer as well. Once the robot identifies the target IDs, the obstacles will be replaced with the target IDs on the Android. Here, it can be seen that it has been done on targets 1 to 3. Lastly, we have the reset button. When pressed, the robot and the obstacles will all be sent to its original position.
The robot does angular turns of 90 and 45 degrees, utilizing the gyroscope on board the STM. Its precision and consistency is due to the use of a PID and OS delays to ensure that the servo motor turns to the correct position. To navigate towards known obstacles and avoid collisions, the ultrasonic sensor at the front of the robot helps determine its relative location.
During task 2, our STM's turning maneuver was initiated by IR sensors that identified the end position of obstacle 2. Our STM's algorithm tracked linear displacement during task 2 by monitoring encoder values. This allowed us to precisely calculate the navigation back to the car park. And to facilitate reliable data transfer and communication, we implemented a standardized communication protocol between RPi and STM using fixed instruction sets and acknowledgers.
We use A-star search to find the fastest Hamiltonian path. Each node represents a point before an obstacle that the robot must visit. Cost is the distance the robot travels. The algorithm combines actual and estimated cost to find the fastest Hamiltonian path.
As you can see, our robot is moving backward while traversing the grid. Our algorithm not only allows forward movements but also backward and diagonal movements. This reduces the inefficiency of fixing it to 90-degree turns, and also it can cut down the time and distance and maintain the accuracy in path.
Firstly, we trained with 4,000 images from RoboFlow and with our own backgrounds and patterns. As the model showed misdetections with similar characters like 7 and 2, we added more images with varied angles, sizes, distances, and darker backgrounds. We then doubled the dataset using augmentations like saturation and brightness, enabling accurate detection in varied environments. Using YOLO V8's instant segmentation, we manually outlined each image with the polygon tool to eliminate background interference and improve shape recognition. We then fine-tuned for 125 epochs with decreasing learning rates and AdamW optimizer, achieving high accuracy.
Our system optimizes video streaming for real-time object detection by using timestamp intervals from Jonathan's capture signal. Instead of relying on individual image captures, we analyze frame timing within the stream to select the largest overlap as the detected image. This accounts for any misalignment by Jonathan or the obstacles, ensuring accurate image identification at any point in the stream, enhancing detection and monitoring. Our two-layer filter prioritizes larger bounding boxes followed by higher confidence levels, ensuring only relevant detections closest to Jonathan are processed. We also excluded invalid images like bullseye from the stream to prevent errors. Our RPi communication includes socket and UDP for live streaming from Pi camera to PC, Bluetooth SPP to Android, USB serial to STM, and algorithm server communication via Flash server, ensuring seamless device connectivity. Multi-threading was also implemented to ensure quick and asynchronous communication between devices.
Sí, Ring. Van a entrar. Allá van.
Guys, I think the heist was a success!